So what is the sigmoid function? It's a must-know concept in artificial intelligence, neural networks, machine learning. So what's the sigmoid function? Any function that looks like a sigma or the shape of S, that's called the sigmoid function. Word just like sigmoid, like sigma, just like we would say humanoid robots, robots that look like humans. Okay. Now the most common sigmoid function that when people say the sigmoid function, they are commonly referring to the logistic function, which is defined as sigma of x is equal to 1 divided by 1 plus e power minus x. It can also be said as e power x divided by e power x plus 1. Okay. And why is it so useful? It's so useful because it maps any real valued number to a range between 0 and 1. So that immediately reminds you of a probability or a Boolean classification. That's why it's so popular. It has a smooth S shape. It's smooth and continuous, and it's commonly used in machine learning neural networks. That's really about it, actually. Its range is 0, 1, domain. It can take any domain value from minus infinity to infinity. It's monotonic, so it's always increasing. If you give an x value that's larger than the previous one, you'll get sigma of x larger, possibly very slightly larger, but still larger. It'll saturate very closely to 1. Even, for example, after 8 or 9, it'll already be 0.99999. And, it'll only continue to taper off, never reaching 1, but approaching it. Oh, there are some other properties. You can say the derivative sigma prime x is equal to sigma of x times 1 minus sigma of x. Also, sigma of x can be written as 1 minus sigma of minus x. It's a fun property, sometimes comes in handy. And why is it so important in machine learning? Like I said, because it can convert any real valued into a probability. Therefore, obviously, it makes sense here. Anytime you have some kind of intermediate output that you want to convert to a final output, you want to decide, is it a cat or a dog? It comes in handy. Similarly, that's a very similar example to in the neural nets. It's historically used as the activation function for neurons. Should this neuron activate or not, you'll get a real valued function. Then you'll come to a 0 and a 1 using the sigmoid, and then you'll have a breakpoint, a cutoff point, after which you'll say it's 0 or it's 1. So therefore, it's very commonly used in the output layer for binary classification tasks here. There are some limitations. For example, it already starts approaching 1. It's too close to 1. There are modern, easier alternatives, but still it's very useful, and that's sigmoid for you.